Hello there, and welcome to the Sleep Whisperer. Tonight, we settle into the immense and quiet story of our planet, a chronicle not written in ink, but in ice, fire, and stone. Long before the first breath was drawn, the Earth was a whirlwind of cosmic dust, a sculptor of continents, a painter of deep time. The ground we trust beneath our feet is a traveler, a shapeshifter, a dreamer in a slumber measured in eons. This is the story of geology, a tale of pressure and release, of emptiness and abundance, of a world in constant graceful motion. Every stone you skip across a pond, every grain of dirt beneath your fingernails, holds the echo of a vanished ocean, the shadow of a long dead star. If these quiet explorations of deep time resonate with you, I invite you to like, subscribe, or share a reflection below. It helps other wandering minds find their way to this peaceful corner. For now, simply breathe. Let the weight of the day dissolve. Allow the ancient, steady heart of the earth to lull your thoughts. Let's begin. The ground beneath your feet is mostly empty space. The solidity of rock is a grand illusion of our scale. If you could see the atomic structure of the most unyielding granite, you would find a miniature universe of vast distances, where nuclei are like lonely stars and electrons swirl in immense voids. The strength of stone is not in its fullness, but in the powerful forces that bind these tiny solar systems together. When you lean against a mountain, you are not pressing against solid matter so much as you are feeling the silent, invisible energy that holds existence itself in form. This emptiness is the true nature of the material world, a reminder that what feels most real is often a delicate balance of force and space, a cosmic dance frozen in a form we can touch. The deepest place on Earth is not on the ocean floor, but in the rock beneath our continents. We speak of the Mariana Trench as profound depth, but if you were to drill into the heart of a stable continent, like the ancient shields of Canada or Siberia, you would journey through crust that tells a story billions of years long. The deepest mines only scratch this surface, a pinprick in the skin of the planet. Beneath that, the rock changes, becoming denser, older, holding secrets from the very dawn of the continents. This deep crust is a world of immense pressure and slow, cooked minerals, a foundation that has supported countless mountain ranges and seas across ages we can scarcely comprehend. The true depths of Earth are not just in its watery abysses, but in the profound, silent layers of stone that anchor our world. Continents have roots that reach deep into the planet, like inverted mountains. Just as an iceberg floats with most of its mass hidden, so too do the continents. These vast rafts of granite and other light rocks are buoyed upon the denser mantle, and they extend downward for dozens of kilometers. These are the roots of the continents, forged in ancient collisions and stabilized over eons. They are the anchors of our world, the keels of the great stone ships that drift on the molten sea below. When mountains are thrust upward, these roots deepen, following a principle of balance and buoyancy that has governed the planet S-shape since the first crust cooled. The landscape we see is only the summit of a much deeper, hidden topography. There are canyons hidden beneath the ice, far grander than any on the surface. Beneath the ice sheets of Greenland and Antarctica lie entire worlds of deep valleys and towering peaks, completely concealed from the sun. Some of these subglacial trenches, like the Bird Glacier Basin in Antarctica, are so vast they would dwarf the Grand Canyon. Their floors have not felt the touch of air for millions of years. These hidden landscapes are sculpted not by rivers, but by the slow, grinding flow of ice, a patient sculptor that carves with unimaginable weight and time. They are a testament to the power of ice, a force that can shape continents as easily as water. But in utter silence and darkness, the sand in the Sahara once formed the floor of a vast ancient ocean, where camels now tread and winds whip dunes into endless waves. There once lay the Tethys Ocean, a warm, shallow sea that teemed with life. The bones of those marine creatures, their shells and skeletons, were ground into the fine sand that now carpets the world's largest desert. The same sands that form a burning, arid landscape were born in the cool, dark depths of a vanished world. A handful of Saharan dust is a handful of ocean floor, a memory of a time when continents were arranged in a completely different order, and the map of the earth was unrecognizable. Some deserts are not made of sand, but of vast plains of polished stone. In places like the Desierto de la Tataca, in Colombia, or the stony desert of Australia, the landscape is a pavement of smooth, rounded rocks. These desert pavements are created over millennia as wind and occasional rains remove the finer sand and dust, leaving behind a layer of closely packed cobbles that fit together like a mosaic. They are nature's tile floor, polished by the abrasive kiss of sand-filled winds. Walking across them is to walk across a natural art installation, one that has been curated by the patient hand of erosion, where what remains is not what was built, but what was left behind. The driest place on Earth, the Atacama Desert, holds landscapes that mimic Mars. Here, rain may not fall for decades, and the very soil is so devoid of life that it is used to test Mars rovers. In this hyper-arid realm, geology is laid bare. Stripped of the softening blanket of vegetation, salt flats stretch to the horizon, their crystalline crusts cracking into hexagonal patterns. Volcanoes, perfectly conical, pierce a sky of impossible blue. The rocks, untouched by water, are covered in a dark desert varnish, a thin layer of manganese and iron oxides that has taken thousands of years to form. The Atacama is a glimpse of a purely geological world, a place where the planet's bones are exposed, and the slow chemical poetry of stone is the only language spoken. Inhaling and exhaling with the changes of the seasons, large cave systems act as lungs for the planet. In the winter, the cold, dense air outside sinks into the cave, exhaling the warmer air within. In the summer, the process reverses, with the cave inhaling cool air and exhaling the warmer air that has been stored in its depths. This breathing is a slow, steady rhythm, a hidden circulation system that regulates temperatures and humidity in the subterranean world. It is a reminder that the Earth is not a static body, but a living, breathing entity, with pulses and cycles that occur completely out of sight in the dark, silent chambers beneath our feet. Some rivers flow not to the sea, but into the ground, vanishing into vast underground networks. In karst landscapes, water does not always flow in surface channels. Instead, it disappears into sinkholes and swallows, diving beneath the earth to travel through labyrinthine cave systems. These subterranean rivers can flow for miles, carving passages in the darkness before re-emerging as powerful springs from the base of a hill. To stand where a river vanishes into the earth is to witness a moment of mystery, a transition from the world of light to the world of stone. It is a reminder that the water cycle is not just a surface phenomenon, but a deep, planetary process that involves the very foundations of the crust. There are lakes that are permanently sealed under ice, isolated for millions of years. Deep beneath the Antarctic ice sheet, like Lake Vostok, lie bodies of water that have been cut off from the rest of the world for epochs. These subglacial lakes are kept liquid by the immense pressure of the ice above and the geothermal heat from below. Their waters are ancient time capsules, potentially harboring unique microbial life that has evolved in complete isolation. Drilling into one is like opening a tomb from another age, a window into a pristine ecosystem that has developed under conditions unlike any other on Earth. They are the planet's most secluded sanctuaries, holding secrets of life, tenacity in the most extreme environments. The water you drink likely fell as rain long before the pyramids were built. Groundwater moves with a slowness that defies human perception. A drop of water that seeps into a deep aquifer in the heart of a continent may take thousands, even tens of thousands of years, to complete its journey through the pores and fractures of the rock. It is water from a different climate, a different world. When it is finally drawn to the surface in a well or spring, it is a ghost from a past age, a liquid memory quenching the thirst of the present. The water cycle is not a quick loop. It is a long, slow spiral through time, and every sip connects us to the rains of ancient history. Glaciers are not just frozen water, they are libraries of the ancient atmosphere. As snow accumulates year after year, it traps tiny bubbles of air within it. As the snow is compressed into ice, these bubbles are preserved, creating a perfect record of the atmosphere at the time the snow fell. By drilling deep into the ice sheets of Greenland and Antarctica, scientists can extract ice cores that go back hundreds of thousands of years. They can analyze the air bubbles to measure past levels of carbon dioxide and methane, and even trace the dust from ancient volcanic eruptions or meteor impacts. A glacier is thus a frozen timeline, a crystalline archive that holds the very breath of the planet across ages. The sheer weight of glaciers depresses the Earth's crust, and when they melt, the land rebounds. During the last ice age, colossal ice sheets, miles thick, covered much of North America and Europe. Their immense weight was so great that it pressed the continental crust downward, like a person sitting on a soft mattress. When the ice melted, the land began a slow, steady rise that continues to this day. In places like Scandinavia and Canada, this post-glacial rebound lifts the coastline by a centimeter or more each year, slowly reclaiming land from the sea. The Earth has a memory of its burdens, and its adjustments are measured in millennia. The ground beneath us is still rising, still healing from the weight of ice that vanished thousands of years ago. Some of the most fertile soils on Earth were born from the grinding of glaciers. The rich, loamy soils of the American Midwest, the Canadian prairies, and the European plain are gifts from the ice ages. As glaciers advanced and retreated, they acted as colossal grinding machines, pulverizing bedrock into a fine mineral, rich powder known as glacial till. This till, spread across the landscape in vast sheets, became the foundation for some of the world's most productive farmland. The breadbaskets of the modern world owe their existence to the destructive, yet ultimately creative, power of ice. It is a profound lesson in geology. What one era destroys, it often gives to the next as a foundation for life. There are rocks that ring like bells when struck. In certain parts of the world, like the ringing rocks of Pennsylvania or the Bell Rock Range in Montana, there are fields of boulders that produce a clear metallic chime when hit with a hammer. These sonorous rocks are typically a very hard, dense basalt, and their ringing property is due to their internal structure and how they have weathered. The rocks are under internal stress, and when struck, they vibrate at a high frequency, creating the bell-like sound. It is a natural percussion instrument, a lithophone that has been playing its subtle music for millennia, waiting only for a stone to act as the clapper. The slowest landslides on Earth move at a pace that is almost imperceptible. These creeping earth flows can advance as little as a few millimeters per year. They are not the dramatic, destructive events of news reports, but a gradual, persistent sagging of a hillside. Houses built upon them may slowly crack and warp over decades, their foundations twisted by the patient, unstoppable motion of the ground. These landslides are a reminder that not all geological movement is sudden and violent. Much of it is a slow, relentless flow, a gradual yielding to gravity that happens in the background of our lives, shaping the land in a way that is only visible over generations. The planet's crust is constantly singing, vibrating from the endless pounding of ocean waves. The Earth's surface is never truly still. Seismographs, sensitive enough to detect the slightest tremors, record a constant, low-frequency hum. This microseismic noise is largely generated by storms at sea, where the energy of crashing waves is transferred through the ocean floor and into the crust, traveling across entire continents. It is the planet's background music, a deep, resonant chord played by the world's oceans on the strings of the Earth itself. Even in the most tranquil, landlocked place, the ground is subtly vibrating with the energy of distant storms. Earth's atmosphere is linked to its geology through a constant exchange of dust. Vast plumes of mineral dust, lifted from the deserts of Africa and Asia, travel across oceans to settle on distant continents. This dust is a vital fertilizer, carrying phosphorus and other nutrients that nourish the soils of the Amazon rainforest and feed the phytoplankton in the Atlantic Ocean. But it is also a geological agent, a fine rain of rock particles that settles on ice sheets, influencing how they absorb sunlight, and on mountains, contributing to the slow process of soil formation. The air itself is a river of stone, a silent, invisible conveyor belt that connects the biosphere and the lithosphere in a global cycle of dust and life. The oldest water on Earth is not in the oceans, but trapped deep in the crust. In the fractures of ancient rock in Canada and South Africa, scientists have discovered water that has been isolated from the surface for more than 1 billion years. This fossil water is a time capsule from a time before complex life colonized the land. Its chemistry can reveal the conditions of the ancient Earth's crust and may even hold clues about the potential for life in similar isolated environments on other planets. Like Mars, this ancient water is a reminder that the most common substance on Earth can also be one of its oldest relics, hiding in the deep, dark places of the world. There are vast, hidden reservoirs of water in the mantle bound within minerals. While we think of the mantle as solid rock, it contains immense amounts of water locked inside the crystal structure of minerals, like ringwoodite. This water is not liquid, but part of the mineral itself. Scientists estimate that there may be several times more water stored in this way in the mantle than in all the world's oceans combined. This discovery rewrites our understanding of the Earth's water cycle, suggesting a whole Earth cycle, where water is subducted with tectonic plates into the mantle, stored for eons, and then released back to the surface through volcanic activity. The oceans we see are just the surface expression of a much deeper, more profound water world within. The first continents formed from the scum of a cooling magma ocean. In the planet's infancy, its surface was likely a global ocean of molten rock. As this magma ocean began to cool, the first crystals to form were dense minerals like olivine and pyroxene, which sank lighter minerals. Particularly the feldspars that are the backbone of continental granite, floated to the top, like scum on a pot of boiling soup. This scum coalesced into the first micro-continents, the seeds from which all future landmasses would grow. The very ground we stand on began as a froth on the surface of a world of fire. Some mountains are not pushed up, but are the remains of a vast eroded plateau. We often imagine mountains rising from flat plains. But in places like the American Southwest, the story is one of subtraction, not addition. The peaks and mesas of Monument Valley are not mountains that grew upward, but the surviving remnants of a once vast high plateau that has been carved away by water and wind over millions of years. They are islands of the past, left standing while the land around them was carried away grain by grain. This is a different kind of mountain, making one of revelation, where the landscape is not built up, but stripped down to its bones. The smooth, rounded Appalachian Mountains were once as tall and jagged as the Himalayas. The gentle, forested ridges of the Appalachians tell a story of unimaginable age and erosion. They are the weathered roots of a mountain chain that soared to Himalayan heights hundreds of millions of years ago, during the assembly of the supercontinent Pangaea. The violence of their birth has long since passed, ground down by 500 million years of rain, ice, and wind. They are geological elders, their sharp edges softened by time, standing as a testament to the planet's relentless patience in wearing down even its greatest creations. There are canyons that are still being formed, and you can hear the rock break. In the remote Sangpo Gorge in Tibet, the Yarlung Sangpo River, one of the most powerful in the world, is soaring its way through the eastern end of the Himalayas. The forces at work here are titanic and ongoing. The sound of boulders grinding in the turbulent flow is a constant, low roar, and occasional rockfalls echo the ongoing work of the canyon as deepening. To stand there is to be present at a geological moment, to witness the raw, violent conflict between the uplift of a mountain and the erosive power of water. It is a landscape in the active voice, a sentence still being written in the grammar of stone. The quietest places on Earth are often the most geologically active: the great deserts, the polar ice caps, the deep sea. These are places of profound silence, where the wind or the deep ocean currents are the only sounds. Yet, beneath this stillness, geology is in constant, vigorous motion. Tectonic plates diverge and converge, volcanoes build new land, and hot springs vent minerals into the abyssal dark. The most dramatic transformations of our planet often occur in the places furthest from human noise, a reminder that the Earth's most powerful work is done, not with fanfare, but in deep, purposeful silence. The world's largest waterfall is not on land, but at sea. The Denmark Strait Cataract, located between Greenland and Iceland, is an underwater waterfall, where cold, dense water from the Nordic seas pours over a vast undersea ledge into the depths of the Atlantic Ocean. This waterfall is 3 times the height of Angel Falls and carries 2,000 times the volume of water of the Amazon River. It is part of the great conveyor belt of global ocean circulation, driven by differences in water temperature and salinity, a process known as thermohaline circulation. This hidden, liquid cataract is a powerful reminder that the most magnificent geological phenomena are not always visible to our eyes, but flow in the dark, shaping the climate and chemistry of the entire planet. The color of a rock often tells the story of its birth and history. The red of sandstone in the American Southwest speaks of iron oxidizing in a dry desert environment. The green of certain basalts points to the mineral olivine, born in the furnace of the mantle. The black of obsidian is the color of rapid cooling, of lava frozen in an instant. The white of pure marble is the signature of a limestone cooked clean of its impurities. A geologist reads a landscape like a painter's palette, each hue a clue to the pressures, temperatures, and chemical environments that forged the stone. The Earth is not a monochrome world, but a canvas of mineralogical color, a record of its own diverse history written in a language of pigment and light. The patterns in stone are a language of mathematics and physics. The hexagonal columns of the giant's causeway in Northern Ireland and Devil's Postpile in California are not random. They form as thick lava flows cool and contract, cracking in the most efficient way to release stress. A pattern governed by the laws of physics. The repeating ripples in sandstone are a record of ancient waves or wind, their wavelength and shape speaking of the velocity of the water or air that formed them. The spiral of an ammonite fossil follows the Fibonacci sequence, a mathematical pattern found throughout nature. Geology is not just a collection of rocks, it is a manifestation of the fundamental principles that govern the universe, written in the most durable medium of all. Some rocks are not native to the place they are found, but were carried by ice from distant lands. These erratics are boulders that were plucked from their bedrock by glaciers, transported sometimes hundreds of miles, and then deposited when the ice melted. A lone granite boulder sitting on a field of limestone is a traveler, an alien in the landscape, its presence a silent map of a glacier's long, vanished path. They are the vagabonds of geology, stones that have journeyed across continents, their origins a puzzle that, when solved, can reveal the flow of ice from a forgotten age. The dust in your home contains microscopic grains of rock from every continent. The fine film that settles on your shelves is a tiny geological sample of the entire planet. It contains clay minerals from distant deserts, salt crystals from ocean spray, volcanic ash from eruptions halfway around the world, and even tiny spherules from meteorites that burned up in the atmosphere. Your home is a museum of global geology, a collection of the world's finest dust, continually curated by the winds. The planet is in a constant state of exchange, and even in the most sealed of rooms, the evidence of this endless silent circulation is always present. The Earth's core is a crystal of iron the size of the moon. At the very center of our planet, under pressures millions of times greater than at the surface and temperatures rivaling the sun, lies the inner core. It is not a liquid, but a solid ball of iron, nickel alloy, and it is growing. As the planet slowly cools, the molten iron of the outer core crystallizes onto the inner core, adding about a millimeter to its radius each year. This gradual freezing of the planet's heart releases heat that drives the convection in the outer core, which in turn generates the Earth's magnetic field. The entire magnetic shield that protects our atmosphere and guides our compasses is powered by the slow, steady growth of a single, colossal crystal at the center of the world. The magnetic field is not a perfect bar magnet. It has weak spots and wrinkles. The South Atlantic anomaly is a region where the Earth's magnetic field is significantly weaker than elsewhere. Here, charged particles from the sun can dip closer to the atmosphere, posing a risk to satellites and spacecraft that pass through it. This dent in our planetary shield is a reminder that the magnetic field is a dynamic, messy, and imperfect structure generated by the turbulent, chaotic motion of liquid iron in the core. It is a living field, one that bulges, weakens, and shifts in response to the deep hidden dynamics of the planet's iron heart. The Earth's rotation is not constant. It is gradually slowing down. The gravitational tug of the moon, acting on the Earth's oceanic bulges, acts as a brake on our planet's spin. The result is that the length of a day increases by about 1.7 milliseconds per century. It is an imperceptible change in a human lifetime, but over hundreds of millions of years it adds up. During the age of the dinosaurs, a day was only about 23 hours long. The planet's spin is a clock that is very, very slowly winding down, its energy being transferred to the moon, which is gradually receding into a higher orbit. The cosmic dance between Earth and its companion is a long, slow waltz of momentum and gravity. The planet's orbit itself slowly oscillates, driving the ice ages. The rhythm of the ice ages over the last few million years is paced by subtle changes in Earth's orbit and tilt, known as the Milankovitch cycles. These cycles alter the distribution and intensity of sunlight reaching the planet, triggering feedback loops that cause ice sheets to advance and retreat. The great pulsing of the glaciers, which has so shaped our modern world, is ultimately conducted by the gravitational music of the solar system, a celestial metronome that sets the tempo for global climate change on a grand scale. The rocks of the ocean floor are the youngest part of the Earth's crust, but they are also the first to be destroyed. New crust is born at the mid-ocean ridges, a fresh skin of basalt welling up from the mantle. This crust then spreads outward, cooling and aging as it goes until it meets a deep ocean trench. There, it is pulled back down into the mantle, recycled into the planet's interior. No ocean floor rock survives for more than about 200 million years. The continents, by contrast, are the elders, some of their rocks surviving for over 4 billion years. The ocean floor is the planet's perpetual youth, forever being born, living a brief geological life, and then being consumed, only to be born again. The very air we breathe is a product of geology. The oxygen released by the first photosynthetic bacteria billions of years ago reacted with dissolved iron in the oceans, precipitating out as banded iron formations, the source of most of the iron we use today. Only after the oceans were rust out could oxygen begin to accumulate in the atmosphere. The composition of our air, the very gas that sustains complex life, was determined by a chemical dance between biology and the iron-rich geology of the early Earth. Our atmosphere is not a separate entity. It is the exhaled breath of the biosphere, filtered and transformed by the mineral world. Life and geology are inseparable partners in shaping the planet. The evolution of land plants in the Devonian period radically changed the Earth's erosion patterns. Roots broke rock apart and stabilized soils, altering the flow of rivers and the chemistry of the oceans. The great coal seams of the Carboniferous period locked away vast amounts of carbon, changing the atmosphere and cooling the planet. The white cliffs of Dover are made of the calcium carbonate skeletons of trillions of microscopic algae. Life is not just a passenger on a geological world. It is one of the most powerful geological forces, capable of transforming rock, water, and air over time. We are living in a geological age named after our own species. The Anthropocene is a proposed term for a new geological epoch, one defined by the profound and lasting impact of human activity on the planet. As geology, our movements of rock and soil now rival those of natural rivers and glaciers. We are altering the atmosphere as chemistry, changing the patterns of erosion and sedimentation, and leaving behind a global layer of novel materials. Concrete, plastic, and aluminum, that will be preserved in the rock record for millions of years. We have become a geological force, our brief time on the planet now etched into its very strata. The story of geology is no longer just about the past. It is about the present, and the legacy we are writing in stone, water, and air for the deep future to read. The world beneath you is a story that is still being written. As you rest, continents continue their slow drift, measured in centimeters per year. Deep in the mantle, plumes of hot rock are rising, destined to birth future volcanoes. In the darkness of caves, water drips, adding a microscopic layer to a stalactite that will outlast entire civilizations. The planet is not a finished work. It is a manuscript in progress, a narrative of change and continuity that extends from its fiery birth to an uncertain future. You are a part of this story. The calcium in your bones was once part of a limestone seabed. The iron in your blood was forged in the heart of a long dead star and delivered to the young Earth by meteorites. The rhythm of your heartbeat echoes the planetary pulses of tide and season. You are not separate from the geology around you. You are a temporary conscious expression of it, a brief, vibrant moment of awareness in a story 4.5 billion years long. So as you drift towards sleep, let this thought cradle you. You are resting on the skin of a living, breathing, ever-changing world. Its past is written in the stone beneath you. Its present is in the quiet, relentless processes that continue through the night. And its future is an open page, a story yet to be told. If these journeys into deep time bring you peace, I invite you to like, subscribe, or share a thought below. It helps other weary travelers find their way to this quiet fire. For now, let go. Let your breathing slow. Let the ancient, steady pulse of the earth lull you into dreams. Sleep well. Good night.